Okay, so again, I'm focusing in on folder D right here. And again, when I go over these notes, I usually like to try to focus on the worksheets just because that's most relevant to like the quiz that you guys take. So I want to make sure I'm preparing you guys as much as possible for that part of it. Okay. Another thing too, with your packets, um, just a reminder that in the library, all 3 packets are there. Okay. So the other day there was some confusion in the library and they put our other 2 packets in the wrong class on accident. So I've sorted that out. So when you guys go in there, you should be able to get all 3. All right. You'll just look for the sign that says my name, Osborne, and you'll see Davies on there because he's the other IM-3 teacher for this quarter. And you'll see it on the top there. It says IM-3 semester 1 or semester 2, packet 1, packet 2, packet 3. Okay. So those guys, you guys can go pick up today. Today, I believe they're closing at 1 o'clock. So the last day of the week, they'll always close at 1 at the library, but they're open at 7:30 every day. So like next week, Monday, Tuesday, Wednesday, 7:30 to 4, and then Fridays they close at 1. Okay. So go ahead and pick those up. Okay, which reminds me, somebody asked me to bring that one later. Should I have this for later? Okay. All right. So again, if like there's issues with picking them up for this week, I have this packet on there. It's online. So you can use that and do it in your notebook or a piece of paper. Just make sure it's organized, like do it neatly, please, and number it and have it nice and neatly done so that it's easy to see. But by next week, I want you guys to have those packets, okay? Another thing, just a reminder about grades. So like, I know some people were asking me in the last class about grades and how it's all laid out. So just a reminder to you guys. Remember that for every week, you're gonna have a grade, okay? So week 1 on Infinite Campus is represented by composite grade 1. And then composite grade 2 is week 2 and 3 and 4 and 5 and 6 and 7, blah, 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 blah. The only one that's going to be different than what you see on the screen is you won't see a grade for composite week 9. You're going to see it for composite exam because the final week is finals. Okay, so I like to use composite exam for finals. And remember, the way it works is that you get a grade for each week, and those are all averaged to give you your overall grade. Now, remember that we're in the even quarter, 2, 4, and 6. So when you go down here, look at the one that says final grade even. Okay, final grade even. And basically that final grade even, that's the average of all those grades. That's your overall grade at that time. So like next week, when I go through week 1 assignments, you're just going to have a grade for week 1. After week 2, you're going to have a grade for both, but it'll be an average of the 2. Okay. So, and if you guys have any issues with that, please, let me know if these guys see something. Okay. And then again, always check your notes on there. Like if I give you like a 0, it's probably just because you like mispost something. Maybe you forgot to post a screenshot, or maybe you posted the wrong assignment on accident. So make sure you guys check those notes. So every time I give you a 0, I'll always say why. And usually it's something you can easily fix, okay? Most of the time. All right. We'll talk about photo math another day. Hopefully you guys are past that. And we won't see any of that on the homework for week 1. All right. So anyways, let's get to the notes. All right, so here's the first one we're talking about. Now with logs, the goal in most cases is to get, for any equation, is to get that variable by itself. All right, now when you have logs on both sides of your equation, this is what's ideal. All right, I want to have a log on each side. And when I say each side, if I divide it down the middle through the equal sign, once I have one log on the left and then one log on the right, I can literally just cancel them. Because technically these are equal. So that means that the answer, or the a part of the log, the a is also equal. So then again, once I have one log on each side, I just set it up like this. I just bring down the a value, which is 5k minus 3 equals 17, and then I just solve that. So now add 3 both sides, and I get 20, and then divide by 5. And k equals 4. All right. So again, for many of these equations, we want if I have log, if log is on both sides, and when I say both sides, I'm talking about both sides of the equal sign. We'll just say that, both sides of equal, then try to cancel them. So if log is on both sides of the equal, should have said sign. It's terrible English. Okay, then try to cancel them. Okay. All right, let's look at another example. Okay, now let's say I've got log of 9 plus log of x plus 7. And that's equal to log of 32. And I forgot to record that, but just for you guys that are watching the recording, again, I'm setting up this problem, and the goal is I need to get these two logs combined into one. And because we're adding the two logs, I can use this property, which if I'm adding the two, I can just multiply the numbers inside, the a and the b, or here in this case, 9 and x plus 7. So now let's do that. And 9 times x plus 7. Now you guys could distribute it if you want. I didn't distribute it just because I want you guys to be able to see where it's all coming from. All right, now I got two single logs on each side. All right, so just like the last problem now I can cancel it. Okay, and now I'm just left with 9 times x plus 7 equals 32. And now we just simplify. So now I distribute the 9x plus 63 equals 32. Try to isolate x. So we subtract 63 on each side. And then 32 minus 63. It's negative 31. And then the last step, divide. And I get x equals negative 31 over 9. And yes, that's okay if you guys end up with a fraction. Okay, still use the same property. Still same idea. Okay, so this time we'll do log base 5 of 6 minus this time. And actually, let's do 6x. So this will be 6x minus log base 5 of, let's say, 8. And then we're going to say it equals 3. Okay. All right, so now we're still going to use that same property, but now it's a minus. So that means we're going to divide those two numbers this time. So again, even though I don't have that log on this side, let's still combine them because there's another way of solving this to be able to get x by itself. So we'll first divide these two. So remember the a goes on top, or the first one goes on top. This goes on the bottom, the a, and set it equal to 3. Now, because I don't have another log on that side, there is another property I can use. And we got to remember that the, like, I don't know, the, what would you call it? The, I don't know if you guys watched the show Flash, and like he's always going to like other universes. what's it called? Like alternate universes and that sort of thing. There's like an inverse, there's an opposite, right? You got Flash and you got Reverse Flash. You got Superman, you got Bizarro, right? There's all these opposites. You guys know I'm a comic fan. All right, so with log, the opposite of log is exponential. So if my log looks like this, my exponential inverse of that is, first I put the base and I raise that number to the e, this number over here, which is the exponent, and then I set it equal to the a value. So that's exactly what we're going to do with this problem. Okay, because if you look at the problem, the b is the 5, the a is the 6x over 8, and then the 3 is the e. And so now we're going to take those numbers and rearrange them into this form. So we're going to go from log form. And now the base, the b, is 5. The e is this number over here, the 3. So that basically it's now 5 cubed. And then the a goes over to the right of the equal sign. That's just the 6x over 8. Okay. All right, so we're not quite there yet. So now we got to solve this equation. So now again, we just moved it and became now exponential. Let me title that over here. This is exponential. All right, and 5 cubed, 5 times 5 times 5. Let's do that. So that's 125. Now, what can we do to solve that type of problem? Okay, so we can multiply 8 first on both sides. And bring that up here. Now, I'm not going to multiply the 8 yet, just because I'm going to do all that work all at once. But what would be the last step here? What do I got to do now? All right, then I'd have to divide a 6 on both sides. All right, so I'm going to do all of that at once. 8 times 125, then I'm going to divide by 6. Okay, let's see. Let's bring up the phone calculator for this one. Oops. So let's see. We're going to go 8 times 125, and then divide by 6. All right, so we get 166.6 and on. So I'll just take like 2 of those decimals. We'll just take 1/10 actually. So we'll round that up to 0.7.
At the bottom, where you wrote 8 in the highlighter, you multiplied both sides by 8 so that they cancel out on one side?
Yep, so that these 8s will cancel.
Okay.
Yeah, that was the whole point of that, was to get rid of that 8 there.
Okay.
So now we got 166.7. Okay, if it's asking for a fraction, you can go to Desmos and do 125 times 8 and then divide by 6. And let's get it to look like what we just did. So 125 times. And then that gives you the answer. If you click on that, it will give you the fraction equivalent. Okay, so in case you want to, because sometimes problems will ask for that. So that's a feature that you guys can use to help reduce your fractions. Okay, now you could have done that here and like figured out a common factor, but use the tools that make things easier. Okay. All right, so let's do 2 more. We'll do 2 more examples. All right. I'm gonna do ones that I feel like you guys will probably need the most. And let's start with imaginary numbers. So we're gonna have 7 minus I, and then 8 minus 4i. Okay, so again, this is complex numbers that we're dealing with here. So complex numbers. All right, so we're multiplying. All right, when we have two numbers in each parentheses, what type of multiplying or what kind of methods can we use to multiply these? What do we got? What's that? Not division, multiplication. What's that? Distribute, right? Distribute. And what's that funny word that we use for knowing how to distribute this one? First, outside, inside, last. FOIL. Okay, so you could FOIL, which is where you multiply the first one, and then the outside ones, then the two in the inside, and then the last numbers. But the one that we've been using in this class a lot is the box. Okay, to multiply 2 by 2 type problems. Okay, when I say 2 by 2, I mean that I've got 2 by 2, two numbers here, two numbers there. All right, so let's set up the box. And where do the numbers go on, the inside or outside? Outside. When we factor, they go inside. When we multiply and simplify, they go outside. All right, so it's, in other words, when we factor, it's like the reverse of multiplying. All right, so now we got 8 times 7, that's 56. 8 times minus I is negative 8I. And you notice I'm doing this little kind of J looking I thing, because a lot of times when they write out that symbol, the I, they do it that way. And the reason for that is because this is not just any ordinary I. It's not just a variable. This actually means something a little different. And we're going to go over that in a second. So here we got negative 4 times negative. So that's positive. But it's I times I, so it's I squared. Now, before we move further, we want to talk about actually we'll add those up and then we'll talk about what I means. So when we deal with complex numbers, we got to remember that there's two parts to a complex number. Okay, so here I'm going to write, we have A, and A is the real part of your complex number. And then the second part of your complex number is the imaginary. So that's why they're called complex, because they have two different parts. One that's real, one that's imaginary. You got flash and then you got reverse flash. Okay? But I guess reverse flash is real too, but I don't know. He's just mad at the other guy. He's jealous. All right, so the reason I need to know that is when I write my answer out, I need to make sure I put the real first and then the imaginary second. All right, so now let's add up all the like terms. So first let's start at the 56, because that's the real part. It's not the one with I. Then we'll add up the combined like terms, which are these two. Negative 8, negative 28, minus 36i. And then we'll write down this last one, 4i squared. All right, but we're not done, because I is something special. I itself, the reason it's called imaginary is because it's actually equal to the square root of, does anybody know what number that is? Minus 1. And it's imaginary because when we take the square root of a negative number, it doesn't work. There is no square root of a negative number. Because when you take a square root of something, you're looking for one number that if I multiplied it twice, it would give me that number, right? So like square root of 9 is 3, because 3 times 3 is 9. But if I did square root of negative 9, well, I can't multiply negative 3 twice to get negative 9. I can't multiply positive 3 twice to get negative 9. So that's why it's imaginary. Now, if I have I squared, that means I'm multiplying I times I, which also means that I'm basically taking the square root of negative 1 times the square root of negative 1. Okay, Now, if I'm going to go over to Desmos and I multiply those two, square root of negative 1 times the square root of negative 1. Okay, it's going to tell me it's undefined because it can't figure out what that is. All right, it doesn't like negatives. So I got to do this on by hand. All right, so now there are limits to calculators. All right, when I multiply two square roots, what I can do is negative 1. I can take those numbers and put them inside the same square root. And now when I multiply those two numbers, negative 1 times negative 1, it's now positive 1. And the square root of 1 is 1. So the whole point of that is that when you get I squared, it's actually equal to 1. So right here, this I squared will actually basically cancel out or disappear because I squared equals 1. So I'm just demonstrating where all that came from, but the point is, know that if you get I squared, it equals 1, okay? So now, this will be 56 minus 36, and now it's 4 times 1 here, so it's basically just 4. So then I have two like terms right there. 56 plus 4 will be 60, and then I have my imaginary part minus 36. Okay? So again, I set that up with the box. I multiplied, combined like terms, and then this one became a real number because that I squared cancels out. All right, I'm just going to do one more example. I want to talk about finding the inverse. Finding the inverse function. Again, these are all, there's like 4 different topics on this last worksheet. That's why I'm kind of going over all these. So this next one, there's 2 problems on the back where it has 2 functions and it's asking you to find the inverse. Now, once you do find that function, you don't need to like make a table to find all the points to graph it. Just use Desmos. Like once you find your function, just type it into Desmos and then sketch it on there, okay? So even this one, just sketch it. And then once you find the inverse of that function, put it in Desmos and then sketch it on there, okay? All right, so finding the inverse, let's start with that. So when you're looking for the inverse of function, it's almost like the opposite of a function in a sense, or the backwardness of the function. This is, I want to think about it like this. I want to say, I'll say for example, let's say I want to plug in 4 to this function. Again, I'm only doing this to kind of demonstrate how we find the inverse. So let's just say that I tell you to plug in 4 to that, right? So if I plug in 4, that means I'm going to plug it into the x. And now we have to think about what are the steps that I would have to take in order to simplify this. What would be the first thing you do? Okay, so what would I do actually? Would I multiply 2 or raise it to the power of 3? What do I do?
Do the 4 first, power 3. Like you do order of operations first,
right? So think about PEMDAS. I would cube first. Okay, I would cube that 4. So 4 times 4 times 4, and that's 64. So that would be step 1. I would cube the 4. Okay, what would be the next step here? What would I do next? Subtract 5 or multiply 2?
Multiply.
Okay, I would multiply. And then so there I would get 128. And then the last step would be what? Subtract. So I had to do 3 different operations to simplify this. All right, so I'm going to use that idea. I'm going to use those operations to figure out the inverse. All right, so over here, let's write first what the function is. So we'll say f of x. First, I cubed it, right? So that means I'm going to take an input and raise it to the third power. Okay, so that's why cubing means x cubed means the same thing. I'm cubing a number. The next step I'm going to do is multiply by a 2. So multiply 2. The third step was that we had to subtract, and in this case, we're subtracting by 5. So that's f of x. That's the original equation. But now to find the inverse, we do everything backwards and opposite. So now, when I'm finding the inverse, now again, I don't know if you guys remember the notation here for inverse. I write the same thing, but then here I put I put that little -1. And now the first step in the inverse is the last step in the original, but the opposite. So instead of subtracting 5, I add 5 first. And then I go to the next one. Instead of multiplying 2, I do what? Divide 2. Just think about the opposite operation. And instead of cubing a number, what's the opposite of raising it to the third power? You do the root. So I'm going to take the cube root instead of raising it to the third power. All right, so I'm going to use that to build the function now. So now first, I would take my input and add 5. So x plus 5. And then whatever I get from that, I would divide all of that by 2. And then the last step would be take all of that and take the cube root of it. And then I just set it equal to that notation there, f of -1, or f of x, the inverse of the inverse of f of x. Okay, so that's finding the inverse. And then what you guys can do, just put that in Desmos, and then you can get the graph and then just sketch it onto your paper, okay?